Hey guys, so I was having some fun this morning over coffee, kind of hacking together some new tools out of some old tools. So lately I've been really enjoying kind of reading and interacting with a lot of the users over on the Lines forum, which is kind of a community of people that have built up and begun sharing ideas kind of spawning out of the Monome products and tools, which are kind of grid-based and now kind of getting into some stranger territories, but started as a grid-based tool for making music. That was kind of build your own function into it. So I've been really wanting to get my hands on some of these tools, but the problem is they're fairly expensive. And I don't have just that kind of money laying around to go out and buy something on just like, I think this is cool. Even though I guess I do that from time to time. But what I thought this morning is I've got a good cup of coffee. I've got some old gear laying around that I hardly use anymore, and I've also got this software called Maximus P that we're looking at here on the computer screen. And maybe you've heard of Maximus P, maybe you haven't. If you haven't, then you should probably go watch a lot more videos before you come back to this one. But if you have used Maximus P or have a basic understanding of a Maximus P, then maybe you'll find this video helpful in how you can breathe some life into some of your old MIDI devices you've got laying around and start to get into some of this stuff. Also, if you haven't been over to the Lines community yet, I strongly recommend going over there. There's really interesting conversation happening there and some really nice, genuine people. So go check it out. But here's what I've done. I wanted to get something kind of going like a Monome. I was inspired by the grid studies that you can find on the Monome page, and I didn't even make it down the first half of the page of grid studies before I was kind of like off and running inspired. So after this video I'm going to have to go back and dive in a little bit more. Okay, here's what we've got. Here's how we're making music with this Launchpad. So I've got it set up so that there's 8 sequences. And we can select one of the 8 sequences by using the buttons on the right-hand side of the Launchpad here. So if I press on number 1, even though we haven't seen any graphic switch here, the 64 pads down the middle here are now representing 8 steps running left to right, and then a major scale running top to bottom. You could change this inside of the max patch or inside of wherever you send the MIDI data generated by this max patch. But right now it's a major scale. So if I just press that first key, we can hear our Do. I can take out some steps. And start changing the music just by tapping in what I want each step. If we're sending the MIDI generated by this max patch to a polyphonic device, we can get chords happening coming out of that. Right now their notes are only as long as the step is, and we can see that running across the top there. But we can already just 8 sequences, 8 steps, major scale, start getting a lot of interesting music happening here. So maybe in our first sequence we get this, we go over to our second sequence, oh my, that one was obnoxiously loud. Let's get rid of that one. But there's just 3 running, and we've already got an interesting thing, and we can come over here and start. Start creating music just by sequencing up all those things. So there's a little bit more functionality to what it does right now. We can start and stop all the sequences using the leftmost, topmost button there, which just toggles, if you look inside the max patch, toggles this toggle in the top left corner there. We can start it again. There's no notes happening, but it's running, and stop it. We can also tap in the tempo using the rightmost up top here. It's not perfect, but it's getting there. So if I go really fast, we can slow it down and stop it again. And that's all the functionality that I've got built into this thing. So nowhere near what most of the apps for the Monome devices are capable of, but this was just a couple of hours worth of work, and everything else has had, I don't know, lots of hours, I would guess. So let's look at how this is actually happening now. So first of all, it's all inside of Maximus P. And right now I've got the patch opened in a presentation view here. We can toggle that in the bottom left-hand corner of our Max patching window. So let's switch out of the presentation view so we can see the guts of this thing. So the way that the Launchpad communicates with our computer and with Max is via USB and sending MIDI over that USB. And for the most part, the pads here are sending note data. So note plus a velocity. So when I drag it once, it sends that note plus 127. When I release it, it sends that note or that pad's note plus a 0. So that's true for the grid of 64 pads here, as well as it's true for the ones down the right-hand side here. The ones across the top are actually sending controller message or continuous controller data for various numbers. And so if we look at the top left-hand corner of our patch, you can see that one object here is set to receive basic MIDI messages coming from the Launchpad S, and the other one is set to receive controller data coming from the Launchpad S. For all that basic note information, I send it into a MIDI parse object, which kind of strips out all or sorts out all of the potential MIDI data that we could be getting from a device, and then I've only got just the note data. So this is just going to be a list of the note and the velocity coming out that bottom there. For the control data, I was starting to experiment with some other things, and so right now I've got it set up so it goes into a subpatcher here. I multiply the control number here by 10, which just pushes it into the thousands. Most MIDI data, or all MIDI data, is going to be restricted to 0 to 127. So just by multiplying it by 10 here, I've pushed it out of that span. So I can later on down the line use that data without having to do some kind of complex sorting to differentiate between the numbers associated with these buttons against the numbers associated with these buttons down below here. So I'm sure there's more elegant ways of doing it. This is just how I've done it here. And then I pass all that data along, whether it be the note numbers and the velocities for these pads down here, or the control buttons here, or those 1,000 numbers, which represents one of the buttons across the top there. I pass all of that along in this box that says prepend, which all that does is it takes whatever argument I've placed after that prepend name, it puts that before any data that we pass into there. So when I press a note on the Launchpad here, it sends in its note number and velocity, but then before that places that pad pressed symbol. So we get, coming out the bottom here, pad pressed, note number, velocity of the pad we've pressed. Then that all goes into this JS object, which stands for JavaScript. So we've actually got a bunch of JavaScript loaded up inside of this object, and we just double click on it. We can see all that JavaScript loaded up inside of there. But I prefer to edit JavaScript in this free application called Atom. It's just a little bit, it's got some more features that makes coding a little bit faster. So let's jump over to Atom and look at how that's all working. So whenever you're working with JavaScript inside of Max, you'll start by declaring how many inlets and outlets you want that JavaScript object back in our Max patch, how many inlets and outlets you want that to have. So if we go back into our JavaScript, we can see that I've told it it's going to have 1 inlet and then 10 outlets. Another thing about the JavaScript inside of Max is it thinks about everything starting at 0. So actually our first outlet, the way we would address that is it's called outlet 0. And then the 10th outlet is actually called outlet 9. Which if you worked in coding before, that'll probably just make sense to you, or you would just assume that. If you hadn't, that can be kind of a confusing thing. So we've declared our outlets, then I declare some variables. The way we control the color of the pads on this Launchpad is by the velocity of the MIDI data being sent back to it. So I went through and I just found which velocity gave me a nice color yellow on this Launchpad, and then I've given that a global variable of yellow. So velocity 51 is a nice yellow here, and then my off color is 0, so that it's no LEDs whatsoever. Then another global variable for holding which grid we've currently got selected, or which grid we're currently editing. Another array of variables, or variable whatever it be, that are all the numbers of the pads on the right-hand side here, so I can quickly figure out which pad I've pressed on the right-hand side, and then another one for the numbers associated that I've now associated with the buttons across the top there, so I can quickly check that incoming pad pressed and see if it's either a right control button or top control button. Then I've got another variable here. It's a big array that is all the MIDI notes associated or assigned to each of the pads here on the Launchpad. And I figured this out by going and looking up the MIDI implementation charts made available by Novation regarding this specific model of the Launchpad. So I knew that the top left corner was associated with MIDI note 0, the bottom right corner was associated with MIDI note 119, and then all of the ones in between. And as you'll see, they're not quite sequential, so when we go row to row, we jump 8 or so values in terms of our MIDI language. And so by using this array, it just was a lot less math to figure out how to just find out, well, which pad did I just press in a generic sense, getting its XY location within that. Then I've got a multi-dimensional array here that's actually representing all 8 sequences and whether or not the pad or these pads are on or off for that specific sequence. So by default, it's initiated with 8 arrays of 64, or I guess 8 arrays that contain 8 arrays of 8 zeros. So each one of these rows is represented by 8 zeros for each of our 8 sequences. And then later on, we'll actually toggle the zeros contained inside of these arrays between 0 and 1 to say whether or not that pad is turned on or off for that specific sequence. So those are all of our arrays. I know there's a much more elegant way of doing things, but as I was kind of scaling and kind of getting this thing going, this was just the easiest way for me to get it going. At some point, I'll probably go back and recode all this, or you can do it. But this is how I got here. So then we encounter our first function, which is that same thing that we saw back in the max patch, pad pressed, followed by the note number of the pad that I've pressed and the velocity. So that's the data that we're passing into this function from max. So every time we press a note inside of max, it sends that data into our JavaScript and calls this function. So then we've got some variables inside of this function. We've got what pad has been pressed, which has just been reassigned to the pad that we've actually received into this function. And then we find out the location of that pad by assigning a variable pad location to equal the results of this function here, get pad location, and then we pass the function pad press. So let's momentarily kind of bookmark that we're here at line 117 and jump down to the function of get pad location. Here's that function, get pad location. We can see it receives 1 bit of data, which is which pad did we press. We can see we're passing it the pad pressed here in the pad pressed function. I know we're saying pad pressed way too many times. So the get pad location receives the pad sent by the Launchpad. And then we declare some default variables. One that is the X location defaults to 0, the Y location of the pad we press defaults to 0, just so that we never have an undefined location. It's always at least this first pad here. And then we've got a for function that says starting with a Y location 0, move or advance as long as Y is less than 8, increment Y. So we'll count from 0 to 7 and assign that value to be Y. And then we'll look through our MIDI pad array, always checking each of those multi-dimensional arrays. So MIDI pads is that function or that array we had way up top here, which we can see is an array that contains 8 arrays. So at Y0, we look at the first array within that array of arrays. When Y is 1, we look at the second array. When Y is 2, we look at the third array, so on and so forth. So we count up to 7, finally look at the last array. And each time we look at those arrays, so we're looking at that array, we're checking to see if that array contains pad press by using this index of function, which if it does contain the note number associated with the pad pressed here, it will return the index number that pad's number index within the array with which it's contained, if that makes sense. If it doesn't find that number inside of that specific array, and this case maybe the first array contained inside of our MIDI pads arrays, then it returns a -1. So in this case, if we look at a specific one and it's -1, then we assign the y location to equal whatever y currently is, so some value between 0 and 7, and then we assign the x location to be equal to the index. Oops, I've done some things wrong here. So, sorry, this is if, as long as we find that note number inside of that array, then we do this thing, rather than if it doesn't find it. So that -1 means it didn't find it. So as long as we didn't find it, then we do these things, which means that it exists inside of the array that we're currently looking at. So we assign the y location to be the same as the array that we found that MIDI number within, and then we assign the x location to be the same as the index of the pad that we pressed inside of the array that we followed. I feel like that was a horrible explanation, but maybe you got it. So we're still inside of this get pad location. And once we've done all of this, we'll return the pad's x location and the pad's y location. So this function returns an array of 2 elements. So then we jump back up to line 117 here, where we called that function get pad location, and we've assigned the 2 elements of that function to be the pad's location. So the x and the y are now contained inside of that thing. Then we break them apart. We assign a new variable pad x location to equal that first array, or that first item of that pad location variable, and then the pad y location to be the second item of that array that we just created using that function. So now that we've got all the data about the buttons that we've just pressed, we now check to make sure if we happen to press one of those right control buttons. So we checked the array that has all the numbers associated with those buttons, and say as long as, or if we found it inside of that array, so meaning it doesn't equal -1, do these things. First thing, make sure it's actually a press rather than a release, so make sure the velocity is greater than 0. And then assign the current grid to equal the index that we found of that one within. So if we press the first one, that's going to find or match that value to be the first value or the first item within the array that is our right button controls, or right control buttons. So whichever of these 8 we press, that becomes the current grid that we're editing. And then we pass that out, the 10th outlet, or in this case what is referenced as outlet 9, plus a 1, so that when I press this one, we update and we say that the grid we're currently editing is 0. But for other sakes, we could also think of that as being 1, the first grid that we're editing. So that's the first thing we want to check for, is if it was a right control button, use that to update what our current grid is that we're editing. If it's not a right control button, so else if it's not a top control button and it's not a right control button, and then once we're inside of that, we check to make sure that our velocity is greater than 0, so it's a press, not a release. So if that's true, and then another if statement, it's just all ifs, just conditionals. So if the get grid value equals 0, so if looking at all of our pads, the one that we've pressed, if it's currently off, then set its grid value using the current x location, the current y location within the current grid, set its value to 1. If the velocity is greater than 0, we didn't press one of these buttons or one of these buttons, and the current grid value is not 0, then set it to 0. So we can safely assume that if it's not 0, it's 1. So let's make it the opposite. Then output all of this data in the form that some matrix controls back over in Max are expecting, so row, column, and then value, so 1 or 0. So that's what we're doing here, is output out an outlet associated with the sequence that we want to update the information for. Then it's row, it's column, and then the value that we've just assigned when we press that button. Then after we've sent all this data or updated all this data internal to our patch, we want to update the display on the launch pad itself. So that function is just calling something, and it doesn't need any data passed into it. It's just calling a function, which starts by counting through all of our columns. So y, as long as y is less than 7, count up through y, and then x running this way, as long as x is less than 8, increment x, and then go through, get the values for all of those pads that we've just stored in that multi-dimensional array up top there. If that is a 1, then make the pad yellow. If that is a 0, then make the pad not yellow, turned off. And that's pretty much it. So hopefully that kind of made sense and you kind of followed that. Yeah. Okay, so let's jump back over to the Max patch and show you what's going on there. So all that data has come into our JavaScript object here, and then it's sorted all that data. The first outlet, which we saw here in the update display, so outlet zeros down here, is sending the MIDI data back out. We make sure that it's reformatted in a way that the Launchpad can expect by using the MIDI format object. And we pass that to a MIDI output, which sends all of the note data back out to the Launchpad to update whether or not it should be yellow or off when we're looking at a specific sequence. Then all the other outlets go to matrix controls. So if I unlock our patch so we can see all these things, we can see each one of these patch chords goes to its respective matrix control, which represents each of our sequences. So if we go to sequence 1 here and I start programming some things in, you can see the same thing that we're seeing on the Launchpad is the same thing that we're seeing on the matrix control there. And so this is a really important point, that sure, we have all of this same data inside of this JavaScript stored inside variables, and we can actually get those variables or reference those variables out into Max and kind of just sequence everything inside of JavaScript. But my experience is that JavaScript is not always processed as time sensitive as the Max or the MSP sides of Max MSP. But sometimes it's kind of pushed off until later. So my preference is whenever I'm sequencing something to do that in the Max patch rather than in JavaScript. So I'll use JavaScript for kind of visual things or some like sorting of data of anything that is not extremely time sensitive, but things that are more time sensitive I'll do inside of Max, and things that are extremely time sensitive I'll do inside of MSP or audio processing. So that's why I've actually got these filling up matrix controls. And this was also inspired by the grid studies on the Monome website, that this is how they started, is filling up matrix controls. So this means that we can actually propagate a matrix control with a sequence, and then we can use the command of get column data to report each one of these columns of a sequence and whether or not a note is on or off. So once we've used our JS to fill this up, now we're just referencing or dealing with the matrix controls inside of Max. So then up top here, we've got a metronome object set up to just count from 0 to 7, which 0 would be column 1 to so on and so forth, the last one being column 7, so we're just counting through these. Using a metronome, and if we open that up, we can see I'm doing some math here to go from BPM to milliseconds to set the rate at which this metronome object sends out a bang, which tells the counter to keep counting from 0 up to 7, then back to 0 again. And then pass that out a few other places. This side of things is just to send colors back out to the Launchpad so we can see our metronome counting across the top. And then the right-hand side goes out to this outlet here, which returns to here, and then goes into this message box that says get column, and then the first variable we receive, so whatever our current count is, get that column from all of our matrices. And then that goes to a send object called get column, which then goes to all of these receivers for all of these bits down here. And then if we just look at the data coming out of our sequence, that's advanced number 4, we can see that when we're at step 4, or column 4, so 0, 1, 2, 3, 4, so we're at this column, we can see that all 8 of the steps within there are set to off. If we adjust that, we resend 4, we can see that now the last one, so this being the first one, this being the last one is now turned on. So whenever we say get column, it reports to us all the ones and the zeros of that column. And then that's sent to an object that's expecting something to be received from seek1, which in this case is down here. So this is receiving it. We could have just patched these straight through together, but it's a little bit tidier sometimes to use these sends and receives, so we don't have patch cables going all over our max patches. So then that goes into an object that I've made, which is included with this Max project called Note and Flash. And I've just done this because arguments are a little bit more useful in this. It's a discussion for another day. But Note and Flash, which does two things. First of all, it prepares the data coming out of this control matrix to be MIDI data again, as well as it sends out a flash to the right-hand column here. So if we get our thing playing here, you can see that this flashes every time sequence 1 has a note. And so that's one of the things that this little note and flash is doing. So if we turn that off, interesting. Oh, that one. We used our mouse to edit. So if we look inside of that, we can see it's taking in that list being sent out whenever we send the get column message into that matrix control. Sends it to two locations. One location to turn that into a flash, which just says anytime we get a 1 in any of those spaces, bang out an 8, which is the note associated with that button there. Turn that into a note that has a velocity of 51 and has the same duration as whatever the duration is of our metronome steps. Pack those together, more format like a MIDI note, send it out of that subpatcher and out to our launchpad to make that one flash. And then on the other side here, we go into play notes, which does something similar. Look at that list coming out of the matrix control. Anytime there's a 1, select that 1 and bang out this MIDI number. So 60, 62, 64, 65, 67, 69, 71, 72, a major scale. Then send all those in, transpose it up an octave. That was just to taste. Turn that into a MIDI note that has a velocity of 60, has the same duration as that of a step within our sequence. Pack those together as their note and velocity pair. Format it as a... Hi, kitty. Come on. Are you coming up or not? Something about cats and Max. So pass that into, or format that as a MIDI message. Come on. There we go. Format that as a MIDI message and pass that out of that outlet. Comes out here, goes back out of this custom object, and it goes out to the MIDI out object. And I've assigned all the sequences to go out a separate IAC bus. If you don't know what an IAC bus is, it's essentially just internal patch cables to send MIDI from one location on your computer to another application or another location on your computer. You can set those up by opening up the audio MIDI setup for your computer, which is found in your applications folder utilities or using Spotlight there. And then let's go and let's open up our MIDI studio, which usually isn't visible by default, so let's open it up. This is where we can see all the MIDI things connected or related to our computer. This red one here, IAC, is where we can establish these interconnections between applications inside of our computer. And so I've set up 8 ports, actually 9 ports, ones that I use for syncing Pro Tools to different DAWs. But 8 ports here called IAC 1 through 8. And then I've made sure that the device is online so that I can use this device. And we can quit out of there. And so each one of these sequences is sending out a different bus on the IAC buses there, or ports there. Which then I've set up Ableton Live with 8 MIDI tracks, all containing the new wavetable instrument on there. And each of them receiving all the MIDI data being sent from the Max patch over those IAC buses in here, which means that now we can sequence or control synthesizers inside of Ableton using our Launchpad in kind of a Monome way. So that was my project today. I'll provide a link in the description below to the Max patch and the code for how I've done all this. Hopefully you guys find this useful and kind of inspiring of go dig through your closet, find some old MIDI gear, and try and turn it into something new by kind of hacking it together in this way. If you don't have a Launchpad S, maybe you've got something else, by all means you can use it with this, but you'll probably have to alter the patch in some ways to reinterpret the MIDI data. Yeah, have some fun with it. Let me know what you guys do with this, and I'll see you in the next one.